Yeah, yalla, let's start. So you already know that we're on this chapter 7. It's about the software development life cycle. It's called systems life cycle. It's software development life cycle, okay? We don't have such systems life cycle. We're just renaming it. And we're on 7.4 implementation. So we collected the requirements, we did our analysis and identified the problems of the current system, and then identified how we could solve this, the solutions, and how can our system solve these problems. And we have the agreement between us as developers and the customers. This is what the system is going to look like, it's going to do. And then you decide on the design. Then they agree on the design, you refine it and stuff like that, and then they agree on the design. And once everything is done, the requirements are specified and the design is there, it's time for you to start developing. After you develop, you test. Once you code it, you test it, okay, to see whether it works and everything works properly. And we have different types of testing, right? Right? Is someone recording? Okay. So, what are the different types of test data? Test data. The types of test data. I studied that last class.
We have abnormal, extreme, and normal.
Okay. أنا أخشق شتيا. Mutian maka, bakwa mutkan. You guys know already that you're not supposed to be opening your mic if you don't need it. And especially if you're in a busy or a noisy environment. Okay. Now, Akar, Daro, Aaron, mute your,
No,
mute your
miss.
mics.
I've muted my mic through my headset.
Yeah, me too.
That is, who's this guy?
Dustin.
Dustin. This noise comes from your mic. Noise.
No, miss, it wasn't Dustin, it was someone else. They just muted themselves right now.
Okay. Yalla, let's continue. Yalla, let's continue. So we have different types of test data, normal, abnormal, and extreme. So once you test it and everything works, you are going to, you're going to start your next stage, which is implementation. This is when you actually implement the system, you deploy. This is what we call, you deploy the system. If you have a website, and everything, you have the design and everything, and you developed it and you tested it and everything is working, then you put it online. That's when we call what we call implementation. Okay, so now it's time to put the system into real life. Specific section is what are the methods of implementation. Okay, we have 4 different methods: direct changeover, parallel, pilot, phased. Okay, and then how can we define which method of implementation is the best, and advantages and disadvantages of each method. Okay. So this is when a completely new system takes over the older system. If you need hardware, you buy the necessary hardware and actually put it into action. You might need to install any necessary data. You might need to install the software itself, okay? And if it needed training, you will need to train the employees how to use the software. And this is actually mostly the case. You need to train the employees how to use the software. So this is the stage where we conduct these steps or processes, okay? And we have 4 methods of implementation. First one is called direct changeover. This is when you deploy the new system and shut down the older one immediately, overnight. Tomorrow you come back to work and the new system is there. You can no longer use the old system. Of course, providing that you have been properly trained as the employee. Okay. The advantage of this is just cheap. It costs less than any other method of implementation. You go, take away the old system and deploy the new system, and that's it. Okay. However, a disadvantage of this is that if it's not properly planned, the organization might have to shut down. You will stop all of the processes going on in the organization if something goes wrong. Okay. That is this method, even though it's easy, even though it's cheap, we rarely use this method unless the organization is so in need of the system and they don't care. Okay. And because it doesn't take much time at all. It doesn't take time. You just deploy it overnight. But we rarely risk pursuing a direct changeover, because if anything goes wrong, the whole company's processes will.
Oh
Huh?
no.
Okay. Any questions regarding direct changeover? No. Okay. The second one is called phased implementation. Okay. This is when what's up? Okay. Guys, it's not funny. You chatting during class while I'm trying to explain something. It's very distracting and it's very disrespectful. I don't need to mention out any names, okay? Let's be serious when we need to be serious. Okay. Phase implementation is when one part of the system is changed, but the rest continue to use the old system. Okay? And I'll tell you what that means. An example of this is when you input the data using the new system, but process the data using the old system. This allows the new input system to be thoroughly tested, actually, and you figuring it out whether it works or not. Okay. So this one, make sure you differentiate this with the parallel implementation as well, because this one, two systems are used at the same time, okay, but not for the same purpose. If you want to take that as a note, not for the same purpose. You input the data using the new system, but process the data using the old system. This is just an example, okay? But with parallel implementation, you use both for everything. We're going to come to parallel. For example, you input using your sensors, if the sensor is the new system, and then you process the data using Excel sheet, your Excel sheet. And the new system to be processed that uses the data processing might be a database, but then again, you still use your Excel sheet and manual data processing for the system. Okay. What could be an advantage of this? What could be an advantage of this? Of phased implementation.
If the new one fails, you can go back to the old one, can't you?
You can go back to the exact what we call point of failure. Okay, because the input system, you use the new system for the input. That means if your input system fails, your input procedure fails, but it's easier to control. Okay, so you can go back. What is this? Okay, you can go back to the exact point. It's very easy to diagnose. Point of failure, if anything, if you get an error.
Isn't it like easier to find the errors because you're only doing one part at a time?
Yeah, it's easy to diagnose. Easier to diagnose. Okay. However you word it, it's totally up to you. What could be a disadvantage? Hmm? What?
More time is needed.
Is it
More.
expensive?
Yeah.
Yeah. It's more expensive than. Who's this ice swallow come? Hmm? Who was this? You can hear me. He just left the group. Okay. An advantage is more expensive than direct changeover.
Miss, it's also more time consuming.
More time consuming because you have to thoroughly test the input system, then move on to the processes, and then move on to the output. You know, it takes more time. It might take up to more than 2 months to, have the new system properly working and taking over. More time than, yeah, it takes more time. Or more time consuming. Because each part needs to be fully tested before moving on to the next. Okay. Third one, pilot.
Miss, can you go back 1 second?
Yeah, sure.
You can go, Miss. Change. Thank you.
You're welcome. Pilot implementation. Okay. This pilot implementation is implementation based on data rather than processes. For example, so the phased implementation was you do the input process using the new system. Okay. But this one, for example, you implement the new system or algorithm or whatever you have on one set of data. If it works, then you move on to the next set of data. Oh, I don't have anything. For example, you can say all Indian results should be done by the new system. If there is no problem, then you move on to the rest. Okay? You take the IGCSE, and let's say Cambridge has a new system for grading your exams, and they implement the new system only on the Indian students or Indian grades. If it works and there's no problem, then they'll implement it on the rest of the world. Do you understand? That's when you say you base the implementation on data rather than processes. You apply it on one set of data. If it works and nothing happens, there's no errors, then you move on to the next. If there are errors, you fix it, and then you try it again, and then move on to the next. Parallel running. This is when both systems are running at the same time, okay? That means you produce two sets of results. Ideally, you are supposed to get the same exact result, okay? The old system and the new system should give you the exact same result that you're looking for, or you intend to. You want it, okay? What could be an advantage of parallel running two systems at the same time?
Miss, if the old
If
of
one
the
of
new
these
one,
system fails, the other can be used as backup.
Exactly. Yes. What else? If the old system, or if the new system, sorry, if the new system has an issue, the organization's processes will not stop. Okay. This is actually an excellent way to test the system using real data. Okay. I'm actually going to write that down because it's a very important point. Excellent way to test the system using real data. What could be a disadvantage? Very obvious disadvantage. Aaron? Aaron.
Miss, can I see it?
Okay, yes, Dylan.
It's time consuming because you need to put in two sets of data systems.
Yes. Yes. Time consuming. An example of parallel running is, for example, some companies do this, but for a very short time. Let's say I'm going to resign in the middle of the year. Okay. Most of the times, the company tells you you must inform us 1 month before. Okay. So you tell them 1 month before that you're gonna that you're gonna resign, and then they're gonna give you 1 month to do what's called a handover. Okay. This handover thing is when they okay, who's this guy? Who's this guy? Seriously. Who is this guy? He's not even here. Hmm? But who is it? This is not funny. I'm trying to. Okay. It's time consuming and it's also very expensive because you're gonna have to pay double for both systems until one of them is fully implemented. Okay. Any questions regarding methods of implementation? So we have direct changeover, we have phased implementation, we have pilot, and we have parallel running. And there's a very nice table on page 142. You can check that out. The objectives of this chapter were, of this specific section was to be able to describe each of these implementation. What is direct changeover? What is parallel? And also be able to lay out the advantages and disadvantages. Okay. This second this point, we're gonna discuss this point regarding different situations. Okay. We're gonna have some sort of practice. They're gonna give you scenarios and they'll tell you what is the best way of implementation. And it's mostly very obvious. It's not something tricky. And sometimes they'll tell you, oh, the company thinks that direct changeover is the best. Please tell why direct changeover is good and why it might not be good. So in that case, it's just another way of telling what is an advantage and disadvantage of direct changeover or any other method of implementation. That's how it comes up in the exam. Documentation. Any questions regarding implementation? Good, good. Documentation. This is when the system is fully implemented and everything is fine and it works, everyone works on it. That's when you start to document. Documentation, some companies do not pay much attention to documentation, but it's very, very important. Okay. You need full documentation once the system is fully developed and deployed. Okay. Why do you need documentation? First of all, you have two groups of target audience when you document your software or your developed software. One group of your target audience is your end users. You might take notes on this, okay? Is your end users, okay? People who use it, okay? That's when you actually document how to use the system, if they get an error, how to fix it, how to install the system, stuff like that. We're going to get to user documentation in a bit. Your second group of target audience is developers. This is when, if you as the developer no longer work for that company, okay, and you leave that company, who will be able to modify your developed software in that company? Of course, other developers. And for other developers to be able to understand what you did and how you developed it and what's going on in your system in the terms of the back end, you need to have proper documentation. Okay. In the company that I used to work for, there was literally no documentation of any software. And it was my responsibility to document everything. And trust me, the developer didn't like it. He just didn't want anyone to know what was going on in the system, because so that no one else can do his job. Okay. So that the company would, you know, wouldn't be able to not to take any orders from this employee, this developer. Some people are very selfish, but documentation is very, very. I'm not gonna tell you. You can do that once you graduate, but for now, you need to be able to know that everything needs documentation. That's enough for now, okay? It's very important. And I'm telling you, I just told you my previous experience, because there was no documentation, nobody knew what was going on, and it was a chaos, okay? Yes, that is lack of professionalism. That's what we call lack of professionalism. So I'm just trying to tell you that these things that you guys study are real, and it's not like something that you will never hear about in your whole life, okay? Okay. Anyways. So we have two different types of documentation: technical documentation and user documentation. Why do we need technical documentation? Explain the need for the technical documentation. Technical documentation is when your target audience is the developers, and I just explained, hopefully you took notes. Why do we need technical documentation? So that if anyone wants to modify it, other developers want to work on your software to modify it or to improve it, to refine it, to maintain it, that's why you need technical documentation. Yeah, sure. Giving fact and information about, I don't know what you're talking about. Is that what's that actually? I'm curious. Okay. User documentation is when this user documentation is mostly the README files. If you have try to install anything, there is a txt file always there. It says README. It tells you how to install the software. It's just a very simple example, but could be more complicated than that. Technical documentation includes the purpose of the system, the limitations of the system, your flow charts, your code, your raw code, annotation, why is this, what does this variable represent, stuff like that. List of variables, the file structure. The file structure is very, very important as well. And then the hardware software requirements and the validation routines. You can see that the user doesn't need to know how you have coded your program. The user doesn't need to see your system flowchart. Who cares? Well, the developers do, okay? That's why you need technical documentation. However, something like hardware and software requirements, the user needs that as well. You need at least a 4 GB of RAM to run this software and this much of hard disk to be able to install and run the software, okay? So there are some common sections in both of the documentation. You should know this, okay? Because there are questions that please state the 2-3 things that are both, that can be found both in technical and user documentation. So user documentation, how to run, how to use the system, sample runs, error messages, troubleshooting guide, frequently asked questions. The book gives you a long list of each of these, you know. Please take a look and read it, because some of the points, make sure you know at least 2-3 points. Create a table for yourself, okay? What are the sections that can be found in both user and technical documentation, and what are the specific sections for technical and what are the specific sections for user, and study these things off of that table, okay? The book doesn't do this for you. You, when you study, create that table for you. I'm not going to do it. You should do something on your own, okay? Because there are questions in the exam, IGCSE exams, that says identify the common stuff between technical and user, and then please identify 2-3 things that are specific to user documentation and 2-3 things that are specific to technical. So explain the need for technical documentation, explain the need for user documentation. And then what are the components of technical documentation and what are the components of user documentation? And these are the components. So, sorry. Here and here. Any questions regarding documentation? Evaluation. Evaluation includes maintenance. It includes repair, okay? Sometimes you need to change the design because the user experience, the real users are not having a good experience with the design, okay? Little things here and there, or maybe major stuff, okay? That's in the evaluation stage. Sometimes you need to go back to your design stage. That's the second stage. Redesign some stuff and then move down the stages until evaluation again. And then if everything went well, then you leave it like that, okay? Because if you change the design, you have to, design includes validation routines as well. You have to, you know, make sure your user agrees on it, and then develop it, and then test it, and then stuff like that. So, software development is such a deep field, so, and it's okay to be deep. So in the evaluation, you evaluate your software against the user requirements. You make sure that you have checked all of your user requirements. If there's something that is missing, it is your responsibility as the developer to add that functionality or meet that requirement, okay? So you have evaluation against user requirements, you have limitations and improvements, and then you have maintenance, okay? All of these things fall under the section, the stage of evaluation. Do I have any? Yeah. The maintenance includes, I think, three major points. We have corrective maintenance, error correction, or corrective maintenance. Actually, let me write it down. error correction or corrective maintenance. Huh? Yeah, they're all both the same thing. Either error correction maintenance or corrective maintenance. It's totally up to you. So when you maintain your software, when the company says we provide maintenance for $300 or $400 a year from now on, once the system is fully developed, deployed, and implementation is done, evaluation is done, testing, everything is done, and they tell you, we developed this software for like $2,000, and then you must provide us with $400 a year for maintenance. This is what they mean. Maintenance includes error correction. If there is suddenly an error in the system, it's their responsibility to fix it. And it all falls under that $400 a year. Okay, added functionality, or this is what we call adaptive maintenance, okay? This one though, for example, okay, let's see. Added functionality, this is what we call. I don't know what to do. I don't know what to say. It's just the internet, and I'm the only one connected to the internet, and I use IQ. Adaptive maintenance includes, for example, okay, for example, you want to, you add your system to another branch / country, okay? For example, Cambridge has a system, and they have to add another school. Another school asks for a license, and they give the school the license, okay? So if this company expands to another country, to another place, and they want the same system to be implemented there, it falls under the maintenance. It's the company's responsibility to go and implement the new system for the new branch. It's the same system, okay? It's not like, okay, I want, maybe, it's not like you want to add something to the system. You don't add anything to the system. If you want to add anything to the system, for that you have to pay more. Doesn't fall under maintenance, okay? Okay. Any questions regarding adaptive maintenance? I don't think this one is in the book. Then we have performance improvements, or what we call perfective maintenance. This you should be able to figure out what we mean by perfective maintenance or performance. For example, you want to upgrade your hardware. It's the company's responsibility to come and upgrade your hardware for you, as long as you pay for your hardware, of course, but it's their responsibility to come and upgrade the hardware for you in order to be able to store more data, okay? Or servers, okay? If you want to upgrade your software, it's totally up to you, hardware, software. So you can see that these are little things going on in the system, and it's the responsibility of the company to provide all of these things for you. Other than that, if you ask for a new design, if you ask for for them to be able to do something else as well as whatever it does for you, that means you add the requirement, then you have to pay. The objectives of this section, I didn't mention it in the beginning, was I wanted to actually explain evaluation before I move on to the objectives and see whether we have met all objectives or not. Describe the need to evaluate a solution in terms of the efficiency of the solution, ease of the use of the solution, the appropriateness of the solution. Describe the need of a variety of evaluation strategies. Example, compare the solution with the original task, identify the limitation and improvements, and then evaluate the user responses to the results. This is a very small section from the book. It's only 1 page. There's not much going on in here. As long as you know what goes on in the evaluation stage. And that's it. And why do we need this stage? Why does it exist in the first place? Why do people bother? As long as you're able to answer these 2 questions, you're fine. Any questions?
No.
No. Okay, we have 10 minutes left. I wanted to actually would you let me take an extra 10 minutes from you if time is up? Next lesson is still ICT. Homework. Homework is once a week. Kill me. Okay. Okay. Homework is homework. Okay. I want to show you something very here. Okay. You go to your Google account. Okay. There's something called, by the way, this is future homework. Like I'm gonna tell you next week, next lesson. It's gonna be due for next week.
Didn't even notice.
There's no Google Forms here. Which account I'm already in? No, I'm not gonna let you go early. Maybe next lesson. Next lesson, I'm gonna let you go early. Okay. Okay, whatever you're talking about, I don't know. Okay. Okay. So, anyways, you go to Google and you go to where is it? Isn't it here or here? It's supposed to be Google Forms are supposed to be here. No. Anyways, you type in Google Forms. Okay. Personal. Now, this is what we call Google Forms. This is what we professionally, there's also something else called SurveyMonkey. Okay. I'm going to show you how that's done as well, but let's first do this one. This is when you design your own. For example, okay. For example, you have a list of teachers, KS4, KS5 teachers. Who do you think is the best? Okay, and why? When we design forms or surveys, we do our best. Actually, let me insert a new slide. Surveys. We do our best to what we call quantify the questions so that we can get, it's easier for the analysis. It's easier when you want to provide reports. So when we say quantify the question, instead of saying that, instead of like short answer questions, you try to avoid short answer questions. So instead of saying please add any comments or whatever, you're gonna say how do you rate this teacher? Okay, And make sure you all, this is going to be homework, guys. So you better pay attention. How do you rate this teacher? And always, you must have some sort of explanation. From 1 being the worst to 5 being the best. That's how you quantify. So you're going to say 50% of the answers are that she is the best or the worst. Okay. Also, you need to change the rate regularly to catch the user's attention or bring back the attention. You don't want someone you don't want someone to constantly say 5, 5, 5, 5, 5, 5. She's the best, he's the best, he's the best, or he's the worst, he's the worst. Okay. This time you change it. Okay. How do you rate this teacher? From 1 being the best to 5 being the worst. Okay. This way you try to minimize errors. Okay. And I'll continue this discussion next class. By the way, you are supposed to design, we're going to discuss this next class as well. You're going to have to design your own survey regarding some specific topic that I'll tell you, and then send it to me, which I'll share it with the school. Hopefully we can get some good data regarding what's going on in the school, okay? And before I let you go, let me take the registration. Akad Amir, is Amir here? Barez and Berzi?
Here.
Okay. Amir is not here. Dia?
She's here.
Lara? No. Mirvin is here. Mirvin? Mohammed Bakhtiar?
Here.
Okay. Prusha?
Here.
Okay. Rasan? Rasan is yes. Okay. And Rawan? Rawan is here, I know, but Rawan.
Miss, that yes was for Laura, not for